Before we get into the show, I wanted to put out a hiring call. I'm looking for my next software engineering apprentice, a young .NET programmer to help me directly with my work, building architectural prototypes, figuring out new patterns, tons of coding. And I'm looking for a .NET programmer whose hobby is also programming. For the right person, programming isn't work, it's play. And besides a job, I can guarantee that you will learn faster than you ever have before. And I will invest in your professional education and we'll work together and you will grow. You'll report directly to me. So if any of this sounds interesting to you, just send me an email or give me a call. Now, let's get into our show. Designing C# and testing a compiler with Jared Parsons.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software engineering firm serving companies with mission-critical software projects. So when failure is not an option, ClearMeasure guarantees your success, and you can find them at clearmeasure.com. Quick announcement, we're in our second year of my architect forums. Signups for the next session are up on the website. If you lead a software team and you're looking to collaborate with some of your peers who are lead architects and who are supervising and running a team of software developers, then this could be for you. Sign up at the link in the show notes. And for those of you looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories. You'll be able to find it. Now, I have today on my show a returning guest back from episode 53, Jared Parsons. And he's the principal developer lead on the C# compiler team. Everybody tuning in probably uses his code on a day-to-day basis. He started out at Microsoft 20 years ago as a developer. He's moved on to become a senior developer and then a principal developer on Midori OS, and most recently the principal developer on the C# compiler team, which he's been on since 2014. So Jared, welcome back to the show. How are you, sir?
I'm doing great. Thanks for having me back.
Oh, my pleasure. My pleasure. Yeah, I didn't realize it's been this long since you've been on the show. We were talking last time about what DevOps looks like for a compiler, which is a very unique piece of software. But a lot of time has passed since then. Now you've been on the compiler team for 10 years. When you started out as a developer, was this your dream job, or how did that end up? If you were to go back in time, how your career kind of steered at Microsoft to basically doing the work that everybody else's work depends on?
I often tell people it's a bit of a funny path because when I was in college, I was kind of one of the lead TAs on the Intro to Compilers class, and I hated compilers. We were doing all this like Lex and Yak and Worth Weber diagrams, and I was like, this is so boring. This is so tedious. This is like, I can't imagine ever doing this as a job. And back when I joined Microsoft 20 years ago, you had to fill out pieces of paper, and you had to checkbox all the things that you were interested in. And I got that list of checkboxes. I'm like, okay, there's compiler and there's web UI development. Check everything else.
Yeah.
And make sure I don't end up on one of those teams. And I ended up on a very different team inside of kind of the dev div, which houses like Visual Studio and a bunch of other things. And after a few years of working on the team, I was like, I was having a lot of problems relating to the customers and things like that. And I wasn't truly happy with where I was. And then my kind of skip level boss, Julia, she moved back to taking over some of the compiler teams. And I was like, you know what? I really like working for Julia, and I at least understand what a compiler is and like what the customer is. And so I'm just going to go try that out and see how that like fits on me. And it turns out that like compilers and languages in a production environment are like super different than what they were in college, and like vastly more interesting for me. And I turns out I have a very big passion for them and get a huge enjoyment out of being in this space. So definitely a bit of a kind of like twisty way into that career path.
Nice. Well, help us kind of get into your head. I know that a lot of people along the way have kind of shaped C#, Anders Hausberg and Mads Torgerson and a number of others. But what does designing a programming language look like? How can you drill it down for people who've never done it before?
So the way I kind of drill down for people is the way I think about languages when I talk to them, like when we do work in C#, is generally these days, if you look back on C# kind of over the last like 7 years or so, when we've been like .NET Core focused and really getting back to our roots of being able to both change the compiler and evolve the .NET runtime and the BCL along with us, where we can basically, instead of saying like, hey, we have these 3 different components, we're just going to do what we want to do and not work with the other team because of limitations in how .NET Framework work. Instead, we have 3 teams. We're like, hey, we have this superpower. We can change the runtime through the libraries, through kind of the language. And so we can do really big things with it. But really, when I look at kind of features in C#, they fall into 1 or 2 buckets. Generally, it's like, are we doing something to make the platform faster? Are we doing something like spanf, where we're going to make .NET faster? We're going to give all these huge building blocks for developers to build really cool stuff. Or are we kind of on the other end of the equation, where we want to make C# a more productive language? We want it to be easier to work with. So you have your things like, you have like link, records, primary constructors, a lot of the minimal API work we did in .NET 7. It's to make it a compelling, like competitive language for people to be productive with minimum ceremony and get their job done. And so often these days, .NET releases effectively annually. So we release in November. So we're kind of on these 1-year ship cycles. And so every year we're kind of planning like, what is the kind of next release of .NET going to be? And that often influences our choices in language design. Usually going into language design, you mentioned Mads. Mads has some big ideas and like, hey, what could we do to kind of keep evolving the productivity side of C#? And then you kind of go and talk to the .NET runtime team and they're like, hey, well, and also other teams at Microsoft, they start talking to us about like, what challenges are we hitting? Like we're trying to push perf in this direction over here. And we're hitting issues, for instance, with like how expensive it was to create delegates at one point, which led us to invest in function pointers, or they're having problems with too much unsafe code in the runtime. And so that invest told us that while we had done a lot of good work with spanf in .NET 7, we did a lot more work to basically push the boundaries of spanf even further and take even more unsafe code and make it into safe. And so usually kind of at that annual cycle, we start getting these like, here are the big problems we need to solve. And generally we have kind of an idea on like, here's kind of the rough shape of what that solution is going to look like. And then from there, it's just finding the right people for the designs. The compiler team, I usually have somewhere between 5 to 9 people working for me on the C# compiler. The C# language design team is much bigger. It has probably 10 to 15 like permanent members. And many of them are very capable at going off and writing their own designs. And so it becomes a very like kind of design heavy process. We spend a lot of time like saying, okay, here are the things we want to solve. We know the shape of the solution probably looks something like this. Now let's go and start speccing it out. And then it's people bringing those specs back to language design. We push and push and push on them for details and start to see like how viable is the solution? Is there a solution here that really kind of fits with the way C# looks and feels? And that can often like be a big struggle for us. I mean, at one point in time, we knew, I mentioned like function pointers we were going to do, which function pointers, like most C# devs are never going to go near them. But it turned out it was super important for performance and some very low level things. And how do you take function pointers, which are kind of very anti-C#, like C# for like delegates and high levels, but how do you make it still look C# enough? And how do you make it fit with that language? And I was one of the people who, we had these rough sketches for function pointers, and I ended up writing a lot of the design for them. And I remember I came back with one of them, and it was just came back with, yes, all of the rules are great, Jared, and this all works out, but it looks terrible. And like, we're not, there's no way we can there's no way this is going to work. And it's like, we need to like kind of like take it and like make it look much more like over here instead. Like you need to embrace the syntax a lot more. And so there's a lot of like, that can be at play in the language design process, is like, how do you make it really look and feel like C#?
Yeah. I've been doing C# since the day it came out. And I remember that, seemed like for the first 10 years, it was just about oh, you know what? We really need this feature. We need that feature. And generics was huge back in, the .NET 2, what was it, 2005, 2000, something like that. And so there's been critical features and certainly link and extension methods. And I mean, it was huge, it changed everything. So now, and I know the design process is mostly out in the open on GitHub, but are there features that just have a lot of discussion that you would classify as, yeah, as much as C# is kind of old now, it's still missing something? Or do y'all think about it as, you know what, no, it's a complete language, but we're just making it better?
Definitely, we feel like there are things that are missing and ways we can make it better. I mean, we have one thing I always tell people, it's like we're not lacking for ideas. We're much more lacking for time. It's more of a resource, and also a little bit of the faster you change the language, the more you kind of force customers to keep up with the evolution. And if you go too fast, you can start you have to find a good balance where you're pushing things forward, but you're not doing it so fast that even like your really excited customers start kind of falling behind and not wanting to keep up with what you're doing. But to give you some examples of things that we know we can make the language better and do things. One is like primary constructors. That is something that's actually very prevalent in programming languages. Like you can find most modern languages have some variation of primary constructors. F#'s had them since F# was a .NET product.
Mm-hmm.
And it's a very compelling feature when you get them. And we've known this for a long time, but we have never really had kind of a good place where it's like, hey, we're really focusing on minimal ceremony here. We need to make this kind of thing better. And we want to kind of invest in that. And that's something like we've been talking about primary constructors since I rejoined the compiler team in like 2014. We just shipped them last year. And even when we shipped them, we knew we could take them a lot further. There are a lot of features we talked about, like could we mark parameters and make them read-only? Could we give them accessibility, generate them into properties? And we held back because we said we're on a yearly ship cadence now. We don't feel compelled to make a lot of like very opinionated decisions on the first release. We can kind of get this out there and get some feedback. Another one's like discriminated unions. That's another feature that we've been looking at for many, many years on the right way to put discriminated unions into the language. And we haven't done it yet because we don't feel like we have the right answers. We have a lot of ideas, but we're still trying to find the nice sweet spot for how we get that feature in, how it works with the .NET ecosystem with versioning and things of that nature. And that can be really gnarly issues to kind of drill down on.
Yeah. Well, I don't think most people even know what discriminated unions is. It would be probably a whole show just to describe it. But you're saying it's out in the open, so they can go on GitHub and actually read up on what these proposals are?
Yep, absolutely. It's on GitHub/.net/C#lang. We have all of our proposals are done on GitHub. I actually just submitted a refinement to one of the proposals I have for .NET 9. I submitted a pull request this morning to kind of some corner cases and getting a little more detail about a little corner case in there. But yeah, all of our proposals are on GitHub. We are a very design-driven team, a spec-driven team. So very much, particularly as we are leading up to presenting things to the language design, we pretty much require you have to have an artifact on GitHub for us to talk about. There has to be something on GitHub that we can put up in the design meeting. It says, here's the feature we're working on. Here are the rules I want to have, and let's kind of work through them one by one. We also have the meeting notes from language design up there. They're indexed by year, and they usually lag behind our meetings by about 3 days to a week. And even as on the compiler team, like once the language design process is a lot of deciding like how should a feature look, how should it feel, and then saying, okay, now it's time to put pen to paper or fingers to keyboards and to get going on the feature. But even as my team, and that's where my team really starts taking over, and we start the actual implementation process. But even then, like we are a very like spec focused team. And so as we're getting into the feature and as we're coding it and we're discovering things we didn't think about in the initial design process, you'll very clearly like see pull requests into the compiler repo where someone's like, we did not think about that case, about how inference works here. And then at the same time, you'll suddenly see a pull request pop up in the C#lang repo that says, okay, we think it's like unanswered question, unexplored question. We're going to go this direction with it. We're going to change the spec and then we'll move on. And then kind of after we get to the end of the implementation, we usually go back to language design and said, like, here's all the decisions we made without you. And we want to make sure you agree with them before we ship this to customers.
Yeah. There's so many developers that have come into the industry just more recently, and it's like the rate of influx just keeps on going up. And one way to learn the language is, hey, the documentation is all out there, but it's just this massive amount. In your view, what's the best how to learn C# path for somebody that's just, you know what, I've been trained in how code works and I understand methods and parameters, but now I want to understand the C# language here in 2024. And I know I can't digest everything, but I really need the high points that kind of 80% of developers most of the time use.
Yeah. I would say I know the kind of intro to .NET. They've had a lot of focus at Microsoft on like, how do we teach people about modern .NET and modern C#? And we have a lot of kind of writings on that on our docs pages, those things. I would definitely say keep focus. That was where I would push people, because we have a lot of focus with that team on like, hey, what are your guys' recommendations for how to approach these type of problems with all the new features that are in the language? And so those courses are usually, those kind of tutorials are very up to date, and very much with the understanding of the people who make the language and make the .NET SDK and the libraries and the runtime. It's very much up to date with kind of our input into it.
Okay.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
And you and your team probably argue over these types of things more than anybody else in the industry. So I want to know your opinion, because we could say, it depends, or, oh, it's take your choice. It doesn't matter. The compiler doesn't care. However, I remember the days where there was the arguments over private fields. Should they be leading underscore and then camel case? And so with primary constructors, it's a new thing. So inside the compiler team, what is your favorite convention for all of the different member types? I know it's subjective, but what's the favorite?
It's funny you say this. The compiler team is extremely opinionated on these things, and we literally just had a debate how like primary. So we are very dog food like rich culture. Like when we do a new feature, it's like, where can we put this in the C# code base to make sure that we are using it, making sure we love it, it has the right design, and we are pushing on it as hard as possible to make sure it's enough quality to give to our customers. We recently had a lot of discussion within the compiler team of what do we want to do with primary constructors, because primary constructors, for those not familiar, it's a way of, instead of having kind of a separate type in a constructor, you just put the constructor on the type definition, and then any of the parameters to constructor, you can just use anywhere in your method. You could just use it anywhere in the type, inside properties, field accessors, members, everywhere. And that was a bit of a scary proposition to the compiler team, because we care it can allow for implicit capture, which is generally not bad in an application. Most people who use this and never care one little bit about it. In the compiler, we are super concerned with how big are things, how big are all the little types that we're creating, because our types are the backbone of Visual Studio. So one field in one of our core types is a very significant increase in like Visual Studio's memory. But also we have like a lot of interop types where we're very concerned with what the layout of these things are. And just these silent captures can start messing with our layouts a little bit. And so we actually had a big team meeting on it, like, what do we want to do? And what we ended up doing was we said, here are the rules that we have for primary constructors. Well, it turns out one of the other features of Roslyn is that we have this thing called analyzers and source generators. It's a way for you to plug into the compiler and basically say, like, here are some rules that I want to enforce in C# that are not necessarily part of the C# team. We went and wrote an analyzer which says, within the compiler, here are the things that we think are legal for primary constructors. And then we are now running that against the compiler code base to make sure that we are very much following the rules that we have laid down. And our rules were very simple. It was just, This is an easy way for us to do fields and properties. So we just basically say you can use the captured parameters, which in a field or a property initializer, and nowhere else. Anywhere else, use a real constructor, make the capture explicit so that we can make sure it's very visible in our code reviews, particularly in kind of our symbol table, which is very allocation sensitive part of the code base.
Okay.
As for underscores and what have you, we use underscores. It was when I first came back to the compiler team, parts of the code base did, parts of the code base didn't. And we basically had a split between like what the VB part of our code base did, what the IDE did, and what the compiler team did. And one of the early influences I had in coming back was saying, we have to fix this. Because it was, not only is it just for me, it would trigger my OCD to see different patterns in different parts of our code.
Yeah.
It was also just a real problem because the line in the Roslyn code base between where the compiler exists and where kind of the IDE exists is not like well defined. Like, yes, we have very specific DLLs that exist in each layer, but code moves between them with great frequency. And we're having this problem of like, people would say, oh, I'm going to take this part of the IDE code and move it to the compiler. Suddenly it doesn't meet the style guarantees, or vice versa. And it was making PRs nightmares. People are arguing with each other like, oh, no, you didn't use underscore here. And it's like, let's just make it simple. And what we did was we essentially went and said, whatever the .NET design guidelines are, we're just going to follow them. And we will invest our time in having a consistent code base. And we will let the .NET, like kind of the .NET design team, like let them just say, like, here are the standards by which we want the code. And that way we can push the burden onto them. We will follow that and spend our mental energy on making an awesome compiler.
Okay, so just a quick review. Private fields, are those still camel case underscore?
Yep.
Okay. Properties, Pascal case, which now that I say it, what the heck is Pascal? New developers have to learn what the heck that was.
I know.
Anyway, okay, so arguments to primary constructors, are those just camel case? Is that official or am I wrong?
For us, it is. For us, we use camel case in our constructors. I think I don't know if the official .NET guidance has been written on that yet. That can sometimes lag a little bit behind it. Usually we'll go sit down with like Emo Landworth on the .NET API team and let him kind of think through what he thinks is the best way to push the recommendations for that. Okay. Like, for instance, when we first did tuples, we had one very opinion on tuples in the compiler team, and then we sat down with like Emo and Stephen Tobe and on the libraries team, and they kind of like spun our head in the other direction. They're like, oh yeah, you should think about it more like this. You're thinking about it as implementation detail. We're thinking of tuples as a grow up to a bigger type. So you should be using Pascal case on your tuples, not camel case, because the goal of these things is one day they might grow up into a real type, and you want to minimize your code churn around them when you do that. So, oh, wow, you're right. That's why we're compiler devs and we're not the API design guys.
Well, I've had some debates with some others in lieu of a hard stance on how the primary constructor coding convention should be. So I'm really glad that you guys have an opinion on it, because you guys designed the freaking thing, and it's going to be easier if everybody else just does it that way. And we all kind of agree. And then there's code out there in the wild, because all these GPT tools are learning from code that's out there. And, it's like, hey, how do you do this? And it's basically, what conventions do I see? And that's what it's going to give. But even more so than that, I've had to explain it to some younger developers, and my mental pattern for them has been, think of it as a class parameter to your method parameter. Method parameters are camel case, and in any of the methods, this is just another argument that's available to you in any of the methods because of the scoping. And so we landed on camel case. I'm glad to hear you say that.
Yeah, that's generally what we've landed on too.
Nice. Now, shipping a compiler and building a compiler and testing a compiler, and just to be sure, in GitHub, is that the entire compiler? Is the entirety of it open source, or are there pieces of it that are still private?
So the compiler exists on .NET Roslyn inside of GitHub. And so that has both the compiler, the C# IDE experience for Visual Studio, our debugging, ENC. It has a lot of our VS Code experience. But so it is a gigantic repo. I often say the compiler, but it is the compiler experience. And it's like, well, the ecosystem around it. It does have the compiler in it. It has the entire compiler. So the entire compiler is open source, like soup to nuts in there.
Now, for developers who want to do that, can a vanilla Windows machine with Visual Studio 2222 just clone that repository and build it, or are there special things you got to do?
The Roslyn team has a deep, deep belief in like, we want our code to look like customer code. We want you to walk to our repo, have Visual Studio, you open the repo and you go. And because we feel it's very important to maintain that experience because it gives us a very like empathetic viewpoint for the customer. And so we very much try to think about like, this is how a customer would approach this problem. We should approach the problem this way. And if our tools can't allow us to approach the problem that way, then we need to go and push on our tools so that we can keep the experience of opening our code in Visual Studio without having big setups. The only kind of things we have in that is we do have a few requirements on just like you have to have a certain version of Visual Studio and a certain version of the .NET SDK because we are often very much dogfooding the latest .NET tooling. And so often it's like you just need to have to make sure you have the right .NET SDK installed. But after that, open. I often tell people it's like you can clone a repo, install the right SDK, open Roslyn, hit F5, another Visual Studio pops up, and now you're just debugging the compiler in IDE.
Nice.
As one little thing.
So if somebody keeps up to date on the 2022 preview versions of Visual Studio, then typically that's you're going to have it.
Typically, yes.
Nice.
Yep.
Nice. Well, that's great because I remember the days of talking about domain specific languages and, you have to start from total scratch, figuring out how to build a, pseudo parser. But with this, I mean, anyone can go and learn the pattern and the flow and just kind of debug through the whole thing. What does it do first, second, third? That's an amazing learning tool.
It really is. It's even learning for us. Like even being here for years, I often forget like how does this work or how that work. It's like it's very easy. Just F5, start putting that code in Visual Studio. I'm like, oh yeah, that's right. This is what we do here. So I'm sure it's amazing for new people and us.
Yeah. Now, are there derivatives of the C# compiler for other uses that you're aware of?
No. So if you go back in the history of Microsoft, you would see things like that. Like I worked on one of them when I worked in Midori. I worked on like System C#, which was a derivative of C#, which was much more like system focused, a little more researchy. But more recently, though, I would say that we've gone away from most of the derivatives and we much more just because a lot of the reasons people wrote derivatives in the past was one, we did not have pre-Roslyn, before we rewrote the C# compiler in C#, we didn't have a good tooling story. If you came to us and you're like, hey, I need to have, like, I'm using C#, but I want some very specific, like I work in this domain with serialization. I want these type of things to happen in my code. We didn't have good answers for you. If you're like, we believe in style, we want to have our own style. We didn't have good answers for you. And someone wrote Style Cop, which was a complete clone of the compiler in C#, like, because we had no tooling to offer them. Like anyone who wanted to have better generation or better this, like there was no story for them. And so they would do derivatives and, make up their own little things. Well, with Roslyn, we had a huge emphasis on tooling when we wrote the compiler. It's pluggable with analyzers. We have the ability for source generators to plug in now. We have a beautiful tooling ecosystem around it. The way that Visual Studio works is the compiler team, we really say we build an API. We have this little library that allows you to inspect code, generate diagnostics, and every now and then emit some code to disk. The C# compiler is like 1,000 lines of code, just calls into the library. The IDE team builds their entire experience on top of our library. They don't have internals visible to us, no special treatment. They just have to use our API as it's designed. And that helps us ensure we can have this beautiful tooling experience around the language. And since then, I would say you'd see more derivatives drift away because the tooling is so much more compelling on what we're building out in the open that people would rather work with that and keep up there and just have their tooling plug in. What they used to do for a derivative now just plugs into the compiler as it naturally exists.
Okay, nice. So the follow-up question, normal application developers, you're constantly thinking about what's going to impact in a positive way 80% or not just a sliver of developers, but the majority of developers in a positive way. You thought with records and primary constructors and default usings and all these features, like we expect code bases to shrink for the same application, right? That kind of thing. Out of all the Roslyn analyzers that are out there that you guys have picked to be in your own in your own project, are there certain ones where within the team you guys say, we expect that these kind of should be used for almost everybody or the vast majority? They're just so basic. It's like it's a no-brainer, where if you were to put on the opinionated hat, you would say, absolutely have this set. And is there a place that developers can learn what that set is?
I would say that for the ones that we do have, we have had a lot of analyzers over the years where we're like, that's a really good idea. Like, we should be putting that into the core product. Like formatting, like, what used to be StyleCop was a very compelling product. Like, people used it for a reason. It was awesome. And now we have kind of a version of that, like our formatting and style analyzers, which are in the box. And all of those are off on a repo called Roslyn-Analyzers, where we have a huge amount of just kind of intrinsic, like, this is good for the .NET ecosystem analyzers. I have personal preferences on them. Like, I love some of the performance ones out there. Errorprone.net is always a fun one to poke around with, because they always find really interesting things to flag as like bad C# patterns. And so I love to look at that one a lot, to just see other people's takes on how that kind of side of the equation works.
Okay. But I think developers could go and just poke into your own build definition in that GitHub repository and see the ones that you guys have enabled, right?
Yep.
Nice. And the build process, I didn't poke in far enough. Does it use Azure pipelines or GitHub Actions? Just curious.
We use Azure pipelines. Okay. And there's a bit of a history with that. We kind of started in Azure pipelines. And at the time, Azure pipelines wanted to move into, for a long time, like, we had Azure pipelines running in GitHub repos. And Azure was doing a lot of work we used to use Jenkins for a long time.
Okay.
And then Azure Pipelines is like, hey, we want to be able to work in the open source, and we want to be able to scale to the craziest people. And so we did a lot of work with them on how to scale to the size of problem that was the C# compiler. And then eventually they scaled up to the size of .NET Runtime. And we have a pretty huge investment in them, because for particular reasons, our official builds all need to be kind of like deep in Azure. But even just moving the amount of work we have in Azure Pipelines, it would be a big lift and shift to move it over to like GitHub Actions at this point. Yeah, there's a lot of kind of underpinnings of the infrastructure that would be a big lift and shift for us. Right.
And then finally, on the subject of opinionated, what are the chosen and thereby favorite testing libraries as you actually test that the compiler's doing the right thing?
We use XUnit as pretty much like our bread and butter with testing. So we have a lot of XUnit and some of the associated plugins on top of that, like combinatorial facts and things of that nature. But XUnit is definitely like the bread and butter for how the C# compiler and most of the .NET team operates their test infrastructure. It's been very both resilient to all of the things we have done in the framework over the years, and it's very pluggable. We have a number of very deep plugins into the XUnit infrastructure. Like, if you look up in kind of the IDE part of the code base, that has very specific threading requirements. Like, you have to be using what are called STA threads in order to test like all of our WPF stuff.
Yeah.
And that might scare a lot of people, but it's like real problems we had to solve. And like with XUnit, it did not in the box have support for that, but we were able to, it had a very rich plugin system or extensibility story. And we were able to like work with it and extend it so that we could run all of our tests in kind of that very specific environment.
Yeah. Nice. Yeah. STA, single threaded apartment. Is that what it stands for?
Yes. We could
ancient history.
So multi-threaded, neutral threaded, single threaded. So all kinds of fun. Apartments, not threads, but we say single threaded. So
yeah. Woo, it takes us back. So most developers don't have to worry about that so much anymore. But Jared, I appreciate you coming back on the show and sharing with us all about the C# compiler team and how you test it and how you design the language. That's something that everybody depends on, and I know I can speak to everybody. We appreciate your work and the work of the team. So thanks so much.
Awesome. Thanks for having me on. It's been great chatting with you.
My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.